Hi everyone. In this video, I'd like to talk about the 3 practice files found in Module 3, and these are needed to complete the Module 3 discussion for this week. So the first file I have open here is called Practice with Environmental Stochasticity. And if you look at the model at the top, this should look fairly familiar. So we start off with an initial population of 1,000 individuals, so P of 1 equals 1,000. And then the way we're going to define the model is that the next step, population, so P of n, it's a function of what happened in the previous time step. So P of n equals last year's population, which is modeled by P of n minus 1, plus 10% more. So we're going to add on 10% of last year's population. And so in essence, what this does is it gives us 1 plus 0.1, that gives us 1.1. It's going to give us 10% more individuals in the population. So this is some sort of growth model. And we could adjust that rate to be anything that we want. So let's just review, building on some skills we picked up in Module 2. We can set the rate equal to 0.1. We can set the initial population to be 1,000. And then we can construct a for loop. Now, notice a couple important things in this for loop. N went from 1 to 9. So when n equals 1, P of n plus 1, in other words, P of 2, equals 1 plus the rate times P of 1. So that gives us our new value, and that will crank us all the way up to P of 10. Okay. Now, we don't always want to construct these for loops and set all these parameters out here in kind of our general document in Maple. Sometimes it's nice to include a code edit region within your file. And so I've done that here. You don't need to redo this, but we do need to run the code. So to run this, we're going to right-click on this window and click on Execute Code. And so you can see what's happening here. It's a for loop. So for n going from 1 up to 10, what we're going to do is we set the rate at 0.1. But if n equals 5, we're going to have a catastrophe. And if n equals 5, we're going to lower that rate down to 0.02. And you can see that at that 5th time step, our population didn't grow very much. Now, as a practice, you should try to modify the code above to make a catastrophe occur at time step 7. So instead of it occurring at time step 5, you could change this to occur at time step 7. Okay, so a different option here is to make a catastrophe happen a certain percentage of the time. So we might not always know that there's going to be a catastrophe at a specific point in time, but we might know that, every 100 years there's going to be a big flood and some people or some cows or whatever we're modeling are going to die. So you can model a catastrophe happen a certain percentage of the time by doing the following. So in this model, you have a random array from 1 to 100. So this is going to generate a bunch of random values. And as we go through the model, if the random value that we're looking at is less than 0.04, then we'll have a catastrophe. So this kind of mixes it up in terms of when exactly that catastrophe will happen. So let's just play around here with the random function. I'll go back up here. We'll take a look at what that looks like. Let's hit enter. So that created a random array. And now if I want to look at the first random number I generated, oops, that did not work out, did it? So let's go back up here and click on the array tools. Now we've got our random list of numbers. Wonderful. Now let's look at that first random number, and that was 0.79, etc. Let's look at hit the number 10. That would give me the 10th number in the list. And indeed, you could scroll over in the array and find the 10th number. And I'll leave it to you to go on the code edit region and run through that code if you'd like to do that. Now let's move over and talk about demographic stochasticity for a little bit. So again, we're looking at the same sort of growth model at the very top here, and we could hit enter here to convince ourselves that our code is working, but it's the same code as we had in the other file. So if we want to incorporate demographic stochasticity, we want to vary that growth rate. Take a look here. I'm going to call a statistics package as well as list tools. And now let's generate some average rates. Now you notice we're not seeing any code pop out because that colon was at the end of the list. In the third file here, you have the same model, and what you're going to do is you're going to incorporate both environmental stochasticity and demographic stochasticity. So reading through the sample code here, you can see where I've called the normal distribution